question with one problem. Let me take that problem. This is the GATE 2004 problem. Let me take pen first. 2004 GATE. Okay. And the problem given as 1K. Here the voltage is 3 volt. Like this. Here the current is IB. Current is IB. Like this given. The current in this is given IC. Perfectly fine. Now the question is, and they have given 4 options also. Option A 56 micro ampere. Option B 140 microampere. Option C 60 microampere. And option D 3 microampere. Now what is the question? The question is, assume VCE saturation is 0.2. So assumption are given. VCE saturation is given 0.2 volt. Okay. Beta for this circuit is also given 50. The minimum base current IB required to drive the saturation, drive the transistor in the figure to saturation. They're asking find out beta minimum which can drive the transistor into the saturation region. So the condition is given that we have to find IC saturation, and the saturation condition what will be the IB. Is it okay? So can we find IC saturation for this circuit? Yes, we can find. Here now we'll take instead of 0.2 because this is mentioned in the question. So I'll start my journey from 3. I'll get 3 minus 0.2 and I'll get 0. This is the potential divided by 1K. So this is 2.8 milliampere. This is IC saturation. If IC saturation is 2.8 milliampere and we have the relation IC equal to beta IB. Is it okay? So by this equation IC you already calculated. 2.8 milli is equal to what is beta? Beta is 50 and IB. So your IB is 2.8 divided by 50 milliampere. Okay. If you'll take it in microampere, so it will be, your current will be 56 microampere. So this is the minimum current of base for which the system will work in saturation. Okay. So the option A is correct. I hope this question is clear to you. It's very easy problem, right? Let me take another question. The question given as simple BJT, base, ammeter and collector. In the collector the current is IC. In the base the current is definitely IB. Is it okay? And beta DC is nothing but the current gain, as you know, because beta DC is nothing but IC by IB. This is kind of current gain. Output is IC, input is IB, right? This is current gain, as you know. Is it okay? Now the question is, if the transistor in the figure is in saturation, this transistor shown in the figure is in saturation. They have given this saturation. This is working in saturation. Now you have 4 options. Option A is IC is always equal to, option 1 is IC should be equal to beta DC of IB. Option B is IC is always equal to beta DC of IB minus of. Option C is IC should be greater than beta DC of IB. Option D is given IC should be less than beta DC of IB. Now tell me which option will be correct. If you remember how to find the region of operation, in which we discussed 3 steps. The step first was to find out the IC saturation. Okay. In the first step, you find IC saturation there. Okay. The first step was over. In the second step, you find IC active. IC active. And IC active is nothing but beta IC. Beta IB. This is beta IB. Okay. So you found in the first case IC saturation. In the second case, you found IC active. In the third case, you compared. In the case first, if IC saturation is greater than IC active, means the transistor was working in active region. Why active region? Because IC saturation is greater than IC active. So it was working in active region. But if IC active was greater than IC saturation, this is faulty condition. This can't be possible with BJT. Why? Because IC saturation is the max current.